Hello, welcome to this lesson. In this video, you are going to solve this question I have on the screen. The question says the masses of the man and the diving board are 54 kilogram and 36 kilogram respectively. Assume that they are in equilibrium. Sketch the free body diagram of the diving board, and then B, determine the reactions at the supports A and B. Okay, supports A and B. Okay, so let's go ahead and look at how you are going to solve this question. So the first thing you have to do is to draw a free body diagram. Okay, so I have my free body diagram here. And then I'll indicate the reaction forces. At point A, we have a pin support there. So you're going to have a reaction force in the X direction and then in the Y direction. And then at point B, you have a roller support there. So you're going to have a reaction in the Y axis direction. And then we have the weight of the diving board, okay, which will act downwards, and then the weight of the man also, which will act downwards. They have the various distances also indicated in the free body diagram. Okay, so now let's look at how you're going to find the reactions at point A and then point B. Okay, so to do this, you're going to apply the equilibrium equations, which says that some of the forces in the x-axis direction should be equal to 0, some of the forces in the y-axis direction should be equal to 0, and then some of the moments should also be equal to 0. Okay, but in this case, you are going to take moment about the first point, which is point A. So let's just indicate that straightforward. So that will be some of moment about point A should be equal to 0. Okay, so now let's consider the equations. If you are considering the first equation, which will be some of the forces in the x-axis direction, you're going to have ax to be equal to 0, which means that ax is 0. Okay, so now let's consider some of the forces in the y-axis direction. But before then, let's look for the value of WD and then WP. So you know the weight of the diving board to be 36 kilograms. So you're going to have the mass to be 36 kilograms. So you're going to have the weight to be 36 times the acceleration due to gravity. And then let's see what you're going to get for that value. So you have 36 times 9.81. Okay, that gives us a value of 353.16 newtons, right? So now let's find the weight of the man also. That also gives us 54 times 9.81. Let's see what you're going to get for that also. So for that also, you're going to have a value of 529.74 Newton. Okay, so now let's consider some of the forces in the y-axis direction. Okay, so for that one also, we are going to have AY, which is pointing upwards, right? And then plus BY, which is also pointing upwards, and then minus WD, okay, minus WP. This should be equal to 0. So now let's bring the values that we know. We're going to have AY plus BY minus WD, which is 353.16, minus WP, which is 529.74, and this should be equal to 0. Okay, so it will be left with one equation because we have two unknowns left still. So now let's look at the last equation. The last equation will be sum of moment about point A. And then as you can see, AX and AY are acting directly at point A, so they will cause no moment. So now let's consider the rest of the forces. So sum of moments rather, not sum of forces. Okay, so considering BY, okay, you consider clockwise moment to be positive and then counter clockwise to be negative. Okay, let's take note of that. So looking at BY will cause a counterclockwise moment. Okay, so that's going to be a negative, and its perpendicular distance from point A is what? 1.2. So you're going to have minus 1.2. Okay, multiplying BY, and then for WD, that will cause a clockwise moment, and then its perpendicular distance from point A will be 2.4. So you're going to have 0.2 plus 2.4 multiplying WD, okay, and then WP also will have a clockwise moment. So you're going to have plus 4.6 WP, and this should be equal to 0. So now let's substitute in the values that we have. Okay, so we are going to have the moment to be minus 1.2 BY, okay, plus 2.4 multiplying 353.16, okay, plus 4.6 multiplying 529.74. This will be equal to 0. So now let's simplify and see what you are going to get. Okay, so we have minus 1.2 by, okay, and then plus 2.4 multiplying 353.16, okay, plus 4.6 multiplying 529.74. Okay, let's see what you're going to get. That will give us a value of 3,284.39, which will be equal to 0. Let's take that value to the right hand side. So we are going to have 1.2 by, okay, equals minus 3284.39. So now let's divide both sides by minus 1.2 divided by minus 1.2 and see what you're going to get for by. So you're going to have 3284.39 divided by 1.2. Of course, the negatives will cancel out, so let's take note of that. And then this will give us a value of 2736.99, okay, newtons for by. Let's change this to kilonewton. So you're going to multiply by 10 to the power minus 3. That will give us a value of 2.74 kilonewton. So now let's substitute this into the equation we have here, okay, so that we can get the value of what? Ay. Okay, so we are going to have Ay to be equal to minus by, right, plus, okay, 353.16 plus 529.74. Okay, we're going to have Ay to be equal to minus 2736.99 plus 353.16 plus 529.74. So let's see what you're going to get. I'm going to add everything together. So you have minus 2736.99 plus 353.16 plus 529.74. Okay, so this will give us a value of minus 1854.09 0.09 newtons. Okay, let's change this to kilonewtons, what you're going to get. So we multiply by 10 to the power minus 3. That gives us a value of minus 1.85 kilonewtons. That will be the value of Ay also. So when you go back to the free body diagram, you see that for Ay, we chose a positive direction, but at the end, the answer is actually telling us that Ay is rather pointing downwards. Okay, and then Ax is 0, and then by is also pointing upwards. Okay, so for the free body diagram, if you are indicating the direction of the reactions, you have to choose them randomly. Okay, your answers will actually confirm which direction they are actually are. Thank you very much for watching this video.